Welcome back. This is the second homework set for CSUB Physics 110. Preview chapter, problem 6. Suppose two galaxies move away from each other at 6,000 kilometers per second and are 300 million, that's 3 times 10 to the 8 light years apart. If their speed has remained constant, how long has it taken them to move that far apart? Express your answer in years. This is a distance, velocity, time type problem. The distance that they've moved apart is 3 times 10 to the 8. That's the 300 million light years. That's the distance light would travel in a time of 300 million years. The two galaxies are moving apart from each other. They've moved that far apart. The speed with which they're moving apart is given in the problem. That's the velocity. 6,000 kilometers per second. We're trying to figure out the time it's taken to get that far apart, moving at that speed. So we know that velocity is distance divided by time. If I multiply both sides of this equation by time, times cancel, time over here, divide both sides by velocity, we get that time, the velocities are canceled, is going to be distance divided by velocity. So that's how we're going to solve for the time. I do see a problem coming up. The distance is given in units of light years. The velocity has units of kilometers divided by seconds. So we have two different distance units. At some point, we're going to have to make a conversion to convert one of those distance units into the other so that they can cancel out. Usually best to do that at the start. So in the textbook, I saw that 1 light year is equal to 9.46 times 10 to the 12 kilometers. So I'm going to make that a conversion factor and multiply that right here. 1 light year is the same as 9.46 times 10 to the 12 kilometers. Note how I've set this up to cancel the light years. So 3 times 10 to the 8th multiplied by 9.46 times 10 to the 12th divided by 1. That is 2.84 times 10 to the 21 kilometers. Now we have all the distances in kilometer units, and we're ready to do our calculation of the time. So our time is going to be this distance in kilometers divided by this velocity in kilometers per second. This number divided by that number is 4.73 times 10 to the 17. The kilometers have canceled. We have 1 over seconds. That's the equivalent to seconds. So there's our time in a very large number of seconds. The problem wanted the answer in years of time, so we need to do conversions. Every 1 minute is 60 seconds, and every 1 hour is 60 minutes, and every 1 day is 24 hours, and every 1 year, hopefully you can see that, is 365, and I put in a quarter, but that's not critical, days. And I got, rounding off, 1.5 times 10 to the 10 years which could also be written as 15 billion years. We've actually made an estimate of the age of the universe because the galaxies are believed to have formed very early on in the age of the universe, and to have moved this far apart at the speed would have taken that long. So that's basically how long the universe has been around. That's more than the age of the universe. The actual best value for the age of the universe is about 13.8 billion years. That's because it's not really a constant speed. Presumably the galaxies were moving apart faster, but gravity slowed them, and so it took less time, because they were moving faster before, to get this distance apart. So again, that was preview chapter, problem 6.